Astronomers have now confirmed the arrival of a massive interstellar object, one unlike anything humanity has ever seen, and it's on a near-Earth trajectory. This visitor from deep space is fast, unstable, and, alarmingly, it's already fragmented once. No force on Earth can alter its path. If it breaks apart again, scientists warn we'll be entering completely unknown territory. This is not a scene from a sci-fi film. This is happening in real time and cannot be halted. This is the tale of the interstellar object that never was supposed to be. It started on July 1, 2025, when astronomers saw something strange, a high-speed body moving through the sky, first identified by the Atlas telescope in Chile. At first glance, it seemed to be nothing more than just another comet, a bright, glowing smear with a delicate tail floating against a background of distant stars. But the longer they looked at it, the more apparent it was that this thing didn't belong in this place. Its trajectory was nothing familiar in our solar system. Mathematics proved that it was on a hyperbolic path, a course that doesn't orbit the sun, but goes right through, never to be seen again. That meant one thing: it had originated outside the solar system. It was only the third time in human history that people had seen an object from a different star system. The astronomers dubbed it 3I/Atlas, the third interstellar, after the historical passage of Oumuamua in 2017 and 2I/Borisov in 2019. But unlike previous visitors, this one wasn't sliding quietly by. Since its discovery, it traveled with a ferocity that struck astronomers as worthy of closer inspection. Clocking in at close to 60 kilometers per second, it was going fast enough that it could travel from New York to Los Angeles in less than a minute. That speed doesn't result from the soft gravitational tugs within our solar system. This object had been on the move for millions of years, and now it was cutting through our neighborhood of the galaxy. "We've only had 3 chances to see something like this," one astronomer remarked, "and this one isn't acting like the others." What set Atlas apart was its erratic behavior. Early orbital models revealed it would make a closer pass by Earth than either of the 2 previous interstellar visitors. But what truly worried scientists were the irregularities in its movement, hinting at possible instability. In contrast to Borisov, which traced a smooth curve, or Oumuamua, which simply had an unconventional shape, this object appeared to be able to change course, particularly if it released gas or broke apart again. By the time it was confirmed by observatories, telescopes worldwide had already been redirected to track it. "Rare to see something from another star system," one of the lead astronomers at the Minor Planet Center explained, "but even rarer when that something starts acting like it doesn't mind breaking the rules." This wasn't just a stray piece of ice and rock. This was a messenger from the depths of space, and its message was anything but certain. Atlas's discovery compelled scientists to reassess how often such interstellar objects could come to our solar system, and if humanity is ready at all to monitor them in real time. It came quietly, yet soon its path started to generate worldwide interest. And just as everything was about to calm down into a familiar routine, something unexpected occurred that stunned even the most experienced astronomers. The unexpected division close to Mars, a few weeks following its discovery, on July 25, 2025, telescopes tracking Atlas started detecting something unusual. Snapshots revealed a second object, faint, tiny, and traveling just behind the central body. It wasn't an error. Various centers, such as the Zwicky Transient Facility, the Very Large Telescope in Chile, and NASA's Scout System, all reported the same. Atlas had broken into 2, and nobody expected it. It happened when Atlas was about 1.4 astronomical units from Mars, roughly Mars to the Sun distance. That's well beyond where gravitational forces would otherwise break it apart. Comets typically break up when they get close to the Sun, where heat gathers in their icy interiors, or too close to a large planet like Jupiter. That's what befell Shoemaker-Levy 9, the comet that famously disintegrated before it crashed into Jupiter in 1994. But Atlas was not even close to either. And yet, it had disintegrated. The world of astronomy was left agog. "Comets don't fall apart on a whim," one scientist said. "It's like seeing a vase shatter in a padded room." The fragment, small and faint though it was, turned everything around. If Atlas would break apart once, then it might break apart again, and any new piece could head off toward Mars or, worse still, toward Earth. What made it even more mystifying was the synchronized motion of the two halves. The smaller piece did not tumble or drift in a wild pattern. It followed behind like a shadow, an almost perfect formation. That level of accuracy implied something greater than a random break, maybe an inner, gradual crack, or something else altogether. In hours, great telescopes were repointed to observe the phenomenon. Engineers ceased planned observations to study Atlas. The information that they recorded would only serve to enigmatize. If this were not a random split, then something much more bizarre was going on with 3I/Atlas. And this was just the start. The next question arrived quickly: why did it split? Comets do break up, and scientists understand that, but in the way Atlas did it, they broke all the rules. Cometary fragmentation is typically near the Sun, where the heat of the Sun builds internal pressure within the comet and its icy surface cracks. Occasionally, the tremendous gravitational pull of a large planet can shatter a comet. But neither of those circumstances befell Atlas ***. When it broke apart, it was still 1.4 astronomical units from Mars, far from both the Sun's warmth and any planet with a strong enough gravitational pull to put such a stress on it. Mars's gravity, by contrast, is feeble. It lacks the mass to rip a 60 km per second comet apart. So what led to the rupture? The spectral data, the light curves, and the readings of the coma indicated no sign of spinning, venting, or gas jets, all the typical fragmentation precursors. Even the comet's radiant coma stayed steady. A breakup would normally produce a flash of light or a change in direction, but all that failed to occur. Instead, researchers observed something more subtle: a low gas-to-dust ratio, i.e., Atlas was emitting more dust than gas, very uncharacteristic of an active comet. Some posited this meant internal structural vulnerability accumulated over millions of years of cosmic radiation. But that still did not account for why it broke so neatly or why its fragment moved in lockstep. The weird thing, said one planetary scientist, is that it fell apart like it had a plan, like it knew what it was doing. Of course comets don't think. But Atlas was defying every scenario scientists thought they understood, and it was evidently not finished yet. The event compelled scientists to look to hitherto unknown forces, perhaps encapsulated gases acting differently from those caused by alien chemistry, or materials created under conditions foreign to our stars. Regardless of the cause, one fact became irrefutable: this wasn't normal, and if it could once occur, it could happen again. The next split might be greater, and potentially lethal. That was a sobering thought, and it spawned a horrifying question: was Earth in its sights? At first, orbital calculations indicated Atlas would fly by harmlessly. Its hyperbolic trajectory meant it was not gravitationally bound to the Sun and would shortly be out of the solar system. But hyperbolic does not equal safe. In space, a tiny deflection can send a trajectory millions of kilometers off course, and Atlas had already been deflected. As a comet disintegrates, its momentum alters. Gas jets resemble miniature thrusters, which can nudge the central mass off course. Post-verified disintegration by Mars, the mission analysts started running fresh trajectory simulations. Scores of models were run across space agencies, and some yielded disturbing outcomes. The central body was expected to fly past Earth safely, but the fragment, or any subsequent debris, might drift into perilous orbital regions. The analogy was swift. The Chicxulub asteroid, which killed the dinosaurs, was originally a close call as well, until minor fluctuations altered its course. The same could be said here, particularly considering Atlas's interstellar speed. Unpredictability is the biggest threat. Non-gravitational forces such as solar radiation and outgassing are uncontrolled and virtually impossible to accurately model. The scariest objects, one NASA planetary defense officer admitted, aren't the ones we're tracking, they're the ones that change mid-flight. It's because of this that 3I/Atlas, previously presumed to be another passing spaceship from outer space, suddenly emerged as a potential menace. Even a minuscule fragment, traveling at interstellar velocity, would impact with the power of a nuclear blast. As simulations progressed, anxiety increased among scientists and defense strategists alike. If it had already broken apart once, might it do it again? And where would the next piece go? Those responses, officials cautioned, would shortly be on their way to Mars, where the next stage of this developing enigma was set to unfold. Atlas and its shadow piece were now converging, and although it wasn't on a collision course, Mars suddenly found itself in the line of fire.